Characteristics of the estimate classes. Detailed descriptions of each estimate class as applied in process industry EPC projects. The 5 estimate classes are not merely defined by percentage completeness. They each represent a distinct combination of scope clarity, usage purpose, estimating technique, effort, and expected accuracy. The following breakdown provides an in-depth look at the unique characteristics of each class, offering a reference for aligning estimate expectations to project maturity and strategic intent. Class 5 Estimate, Concept Screening. Alternate names, Order of Magnitude Ballpark, ROM, Rough Order of Magnitude Blue Sky Idea Study, Guesstimate. Scope Definition, 0% to 2% complete. End Usage, Market Evaluation, Initial Viability Assessment, Project Location Screening, Resource Planning and Long-Range Capital Forecasting, Estimating Methodology, Capacity Factors, Lang, Hand, Peters-Timmerhouse, Ratio-Based Modeling, Cost Capacity Curves, Guthrie Factors, Analogy or Experience-Based Assumptions, Accuracy Range, low, -20% to 50%, high, +30% to 100%. Effort to prepare, 20 millimeter project, 1 hour to 200 hours, dependent on tools, scope, and urgency. Class 4 Estimate, Study or Feasibility. Alternate names, Screening, Top-Down, Pre-Design, Authorization, Factored Estimate. Scope Definition, 1% to 15% complete. End Usage, Strategic Project Comparison, Pre-Approval of Concepts, Evaluation of Alternatives or Expansion Phases, Justification for Feasibility Stage Funding. Estimating Methodology, Equipment Factored Methods, Parametric Modeling using System-Level Correlations, Preliminary Unit Cost Ratios, e.g. per kilowatt dollar a ton, Accuracy Range, low, -15% to 30%, high, +20% to +50%. Effort to prepare, 20 millimeters project, 20 to 300 hours. Class 3 Estimate, Budget Authorization and Control. Alternate names, Budget Estimate Sanction, Semi-Detailed, Preliminary Control, Basic Engineering Phase Estimate. Scope Definition, 10 to 40% complete. End Usage, Formal Budget Approval, Funding Allocation, Initial Control Baseline for Tracking Costs and Schedule, Estimating Methodology, Assembly Level Unit Cost Breakdown, Discipline-Based Quantity Takeoffs, Mixture of Deterministic, Line Item Costing, and Stochastic Factored Methods for Unrefined Areas. Accuracy Range, low, -10% to 20%, high, +10% to +30%. Effort to prepare, 20 millimeter project, 150 to 1,500 hours. Class 2 Estimate, Control or Bid Tender. Alternate names, Definitive, Execution Phase, Master Control, Engineering, Tender, Change Order Estimate. Scope, Definition, 30 to 70% complete. End Usage, Competitive Bidding, Detailed Procurement and Construction Control, Change Management and Scope Variation Analysis. Estimating Methodology, Full Deterministic Methods, Detailed Unit Cost Buildup from material quantities, labor rates, productivity factors, Use of forced takeoffs when detailed design is incomplete. Accuracy Range, low, 25% to 15%, high, +5% to +20%. Effort to prepare, 20 millimeter project, 300 to 3,000 hours. Class 1 Estimate, Final Check or Bid Validation. Alternate names, Bottoms Up, Firm Price, Detailed Control, Fair Price, Current Control Estimate. Scope Definition, 50 to 100% complete. End Usage, Final Cost Validation before Contract Award. Subcontractor Bid Reviews and Negotiation Support. Dispute Resolution and Claim Assessment. Current Cost Control Baseline for Execution Phase. Estimating Methodology, Highly Detailed Deterministic Costing, Individual Unit Rate Application to Fully Defined Quantities, Subsystem Level Costing for Schedule and Commissioning, Accuracy Range, low, 3% to 10%, high, +3% to +15%. Effort to prepare, 20 millimeter project, 600 to 6,000 hours, highest granularity and accuracy. Summary. Each estimate class represents a calibrated balance of speed, accuracy, and purpose. The transition from Class 5 to Class 1 reflects increasing confidence and control, with higher effort and more refined input. Understanding these distinctions allows organizations to assign realistic expectations, apply the correct estimating techniques, and communicate project status transparently across phases, from idea to execution. Class 5 Estimate, Concept Screening, Early Stage Low Definition Estimate for Strategic Evaluation and Project Screening. Class 5 estimates represent the earliest and least defined stage of project cost estimation within the process industries. They are typically generated with minimal input data and are used primarily for strategic decision-making, concept screening, and preliminary economic assessments. These estimates carry the widest range of uncertainty, but are essential for evaluating whether a project is worth pursuing further. Alternate names and synonyms: order of magnitude estimate, ballpark estimate, rough order of magnitude, ROM, blue sky estimate, idea study, seat of the pants estimate, prospect or guesstimate, concession license estimate, rule of thumb estimate. Open quote, note, these names may be used interchangeably in industry, but are not formally standardized. Use with caution when correlating with classification systems, close quote. Description and context. Class 5 estimates are typically prepared with very limited information. They are suitable for preliminary project viability screening, market and location studies, initial scope identification, high-level budgeting and strategic capital planning. At this stage, the known information might include only proposed plant capacity, general location, plant type, e.g. refinery, ammonia unit, etc. Level of project definition required. 0 to 2% of full project definition completed. Engineering inputs are generally non-existent or extremely preliminary. End usage, used to support high-level business decisions such as market studies and location comparison, long-range capital planning, budget forecasting and economic feasibility assessments, screening alternative concepts or routes. Estimating methods, typically used: stochastic parametric approaches, including capacity factoring, Lang, Hand, Guthrie, Peters, Timmerhouse, Chilton, ratio methods based on dollar unit capacity, historical analogy and judgment-based estimates, use of modeling techniques or multipliers with limited design basis. Expected accuracy range, low side, minus 20% to minus 50%, high side, plus 30% to plus 100%. Range varies significantly depending on technological complexity, similarity to past projects, quality of available analog data, application of appropriate contingency. Effort to prepare for a $20 million project, as little as 1 hour up to 200 hours, influenced by estimating approach used, whether tools or templates are available, skill and familiarity of the estimator with the type of facility. Summary. Class 5 estimates serve as broad-brush feasibility indicators. While inherently imprecise, they play a pivotal role in portfolio strategy and early project justification. Given their wide error margins, they should never be used for commitment-level decisions or detailed comparisons without further refinement. Their strength lies in speed and simplicity, not precision. Class 4 estimate, study or feasibility intermediate level estimate for strategic planning, feasibility evaluation, and preliminary budget approval. Class 4 estimates are prepared during early project development when partial engineering deliverables become available. These estimates support business case refinement, strategic approvals, and economic feasibility checks. Although more reliable than Class 5, they still carry a wide accuracy range due to the incomplete scope definition. They form a bridge between conceptual assessment and structured budgeting. Alternate names and synonyms: screening estimate, feasibility estimate, top-down estimate, authorization estimate, pre-design or pre-study estimate, factored estimate. Open quote. These alternate terms may vary across organizations and do not always align perfectly with formal classification. Close quote. Description and context. Class 4 estimates are based on limited but structured information, typically developed after preliminary engineering begins. Common uses include validating the technical and economic feasibility of a concept, securing funding for the next development phase, screening competing options or facility configurations, supporting strategic business development or internal project prioritization. At this stage, some or all of the following inputs are generally available: preliminary block schematics, process flow diagrams, PFDs, for key systems, initial plant layout and plot plans, preliminary engineered equipment lists, level of project definition required, 1 to 15% of full project definition. Engineering documentation is limited but structured. Some cross-functional review may have occurred. End usage Class 4 estimates are typically used for feasibility studies and comparative option analysis, high-level approval to proceed with further engineering, long-term planning and resource allocation, screening and ranking of capital investment opportunities. Estimating methods. Typically used, primarily stochastic techniques such as equipment factoring, Lang, Hand, Guthrie, parametric modeling using cost-capacity relationships, Chilton or Peters-Timmerhouse multipliers, top-down ratios and gross unit cost models, e.g. ton of output or kilowatts, hybrid methods for partially defined subsystems. Expected accuracy range. Low side might have 15% to 30%, high side with 20% to 50%. Variability depends on degree of scope clarity, quality of analog data, use of contingencies, and escalation strategies. Effort to prepare for a $20 million project. Typically 20 to 300 hours. Depends on complexity and size of the project, detail available from engineering, availability of templates or historical data, internal review cycles. Summary: Class 4 estimates introduce a degree of structure and quantification that enables early investment decision-making and risk-filtered comparisons between options. While still reliant on parametric models and assumptions, they reflect increasing clarity in process definition and physical layout. These estimates are essential for feasibility validation and for gaining early-phase stakeholder alignment, but they are not suited for final budgeting or contracting without further refinement. Class 3 estimate, budget authorization and control baseline estimate for project funding, cost monitoring, and scope validation. Class 3 estimates represent a critical transition point in the project lifecycle, where preliminary concepts give way to structured design and cost control planning. They are typically used for full project funding requests and serve as the initial cost control baseline. With moderate to high levels of scope definition and structured inputs, these estimates balance detail and flexibility, making them essential for strategic approval, early procurement planning, and internal accountability. Add alternate names and synonyms: budget estimate, sanction estimate, scope estimate, preliminary control estimate, basic engineering phase estimate, target estimate, development phase estimate. Open quote, terminology may vary across organizations. However, the essential feature of Class 3 is its role as the first control estimate. Close quote. Class 4, description and context. Class 3 estimates are based on moderate definition of the project scope, typically incorporating a range of early design documents. Typically used to secure full project budget approval, establish internal funding allocations, create an initial cost tracking baseline, set procurement and construction cost expectations. Input deliverables often include process flow diagrams, PFDs, utility flow diagrams, UFDs, preliminary piping and instrumentation diagrams, PNIDs, plot plans and early layout drawings, preliminary equipment lists, and data sheets. Level of project definition required, 10 to 40% of total project definition completed. Engineering development is advanced enough for semi-detailed costing and functional review. End usage Class 3 estimates are commonly used for full funding or financial sanctioning by stakeholders, establishing project cost control and variance monitoring, decision support for long lead procurement and early construction phases, basis for project schedule and contingency planning. Estimating methods. Typically used, mixed deterministic and stochastic techniques such as assembly-level unit cost buildup per equipment system, semi-detailed line item costing, factored or ratio-based methods for non-critical or undefined elements, early vendor quotations or analog pricing for key packages, expected accuracy range, low side plus 10% to 20%, high side plus 10% to plus 30%, accuracy influenced by quality of input documentation, degree of design review completed, extent of scope exclusions or assumptions, vendor pricing certainty, and escalation assumptions. Effort to prepare for a $20 million project, typically 150 to 1,500 hours. Effort driven by project complexity and technical novelty, required breakdown level, discipline-wise, system-wise, number of stakeholders requiring review and alignment, quantity of third-party inputs, vendor data, benchmarking, etc. Summary. Class 3 estimates function as the budget cornerstone for most capital projects in the process industries. They provide a structured and partially detailed cost picture, enabling both internal authorization and external accountability. While not yet granular enough for final bidding or execution, they are reliable enough to launch early procurement, establish cost controls, and begin performance monitoring. They also act as a foundation for comparison with later estimates, Class 2 or 1, as project execution unfolds. Class 2 estimate, control or bid tender high-definition estimate for contracting, execution planning, and change management. Class 2 estimates are developed when substantial engineering and design documentation is available. They serve as the detailed control baseline used for contractor bidding, owner procurement decisions, and execution phase cost management. These estimates rely heavily on deterministic methods and detailed quantity-based costing, making them suitable for tender evaluations, contract negotiations, and full-scope financial control. Alternate names and synonyms: definitive estimate, master control estimate, execution phase estimate, bid or tender estimate, engineering estimate, change order estimate, detailed control estimate. Open quote, while terminology may vary, Class 2 estimates are consistently associated with high-definition scope and formal contracting. Close quote. Description and context. Class 2 estimates are based on substantially defined scope, typically incorporating a wide array of finalized or near-finalized design documents. Used to establish detailed cost baselines for project execution, evaluate and compare competitive contractor bids, issue procurement packages and tender documents. Define scope for change order control and claims evaluation. Input deliverables generally include final or near-final process flow diagrams, PFDs, and utility flow diagrams, UFDs, piping and instrumentation diagrams, PNIDs, plot plans and final layout drawings, heat and material balances, detailed equipment lists and data sheets, single-line electrical drawings and cable schedules, vendor quotations, and execution planning documents. Level of project definition required: 30 to 70% of project design completed. Documentation typically sufficient for full scope quantity takeoffs and resource planning. End usage Class 2 estimates are intended for bid, tender pricing by contractors or subcontractors, final owner budgeting before construction, procurement strategy alignment and negotiation support, execution phase cost and resource monitoring, change management baseline for cost control and scope tracking. Estimating methods. Typically used predominantly deterministic methods, including detailed unit cost buildup using takeoffs from design documents, discipline-wise quantity and labor rate application, force detailed assumptions for areas not yet fully defined, subsystem level breakdowns with vendor validated pricing, material, equipment, labor, subcontract, and indirect cost segregation. Expected accuracy range: low side 5% to 15%, high side plus 5% to 20%. Accuracy dependent on completeness and consistency of input documentation, vendor quote quality and pricing date, complexity of site conditions, logistics, and schedule, use of current escalation and risk-adjusted contingency assumptions. Effort to prepare for a $20 million project, typically 300 to 3,000 hours. Higher effort if estimate is being used for formal bid tender submission. Multidiscipline teams or work packages are involved. Extensive vendor coordination is required. Multiple internal review and validation cycles are needed. Summary. Class 2 estimates represent a high-precision, execution-ready cost structure for complex EPC projects. Their robust detail enables confident tendering, scope alignment, and contract finalization. These estimates become the reference point for scope variation, change orders, and earned value monitoring during construction. While time and resource-intensive to prepare, they offer the clarity and control needed to navigate the financial realities of major capital project execution. Class 1 estimate, final check or bid tender validation. Fully detailed estimate for execution control, bid evaluation, and claims resolution. Class 1 estimates are the most detailed and refined estimates prepared during a project lifecycle. Developed when nearly all engineering and design deliverables are complete, they serve as the final control baseline or check estimate for execution, contract negotiation, and claim validation. Typically used for high-value or high-risk project segments, Class 1 estimates provide the narrowest accuracy range and demand the greatest preparation effort. Alternate names and synonyms: final estimate, bottoms-up estimate, firm price or tender estimate, release estimate, detailed control estimate, bid check or fair price estimate, execution phase estimate, current control estimate. Open quote. While multiple terms are used, Class 1 estimates universally represent complete high-confidence projections. Close quote. Description and context. Class 1 estimates are prepared when the scope is fully defined and nearly all design documentation is finalized. Commonly applied to bid check and tender comparisons, final contract negotiation and award, subcontractor pricing and claims evaluation, establishing updated execution phase cost baselines, typically includes complete engineering and design packages, final equipment specifications and vendor pricing, fully detailed construction and commissioning plans, execution schedule, logistics, and manpower plans. Level of project definition. Required 50 to 100% of project definition completed. All disciplines, mechanical, electrical, civil instrumentation have issued complete or near complete deliverables. End usage Class 1 estimates are used for final control baseline against which all actual costs are tracked, contractor bid evaluation or comparison with in-house projections, negotiation of contract price, terms, and change orders, legal support for claims analysis or dispute resolution, budget true-up for execution readiness. Estimating methods, typically used, exclusively deterministic methods such as bottom-up costing of all components, materials, labor, equipment, detailed quantity takeoffs from final IFC drawings, line item level pricing from vendor quotes and in-house rates, allocation of indirects, contingencies, and construction allowances, integration of commissioning and startup costs. Had expected accuracy range, low side, my 3% to 10%, high side, plus 3% to 15%. Accuracy depends on timeliness of vendor pricing, design stability at the time of estimation, consistency of schedule and resource planning, site-specific risks and escalation inputs. Effort to prepare for a $20 million project, typically 600 to 6,000 hours, highest effort among all estimate classes, influenced by quantity of systems discipline packages covered, review loops with project teams, contractors, and management, integration with procurement, legal, and project controls functions, bid package complexity and scope. Summary. Class 1 estimates deliver the highest level of precision and accountability in the estimating spectrum. Used sparingly due to their intensive effort, they are typically applied to critical path packages, final bids, or contractual disputes. With complete documentation and refined cost granularity, they offer the confidence required for commercial agreements, risk allocation, and detailed construction cost tracking. They are the financial final word before breaking ground or settling claims.